So this question is related to the equilibrium constant for acid and alkali. Carbonic acid is a weak acid which dissociate in two stages. So Ka1 and Ka2 is given. Like H2CO3 dissociate into first HCO3, then HCO3 dissociate into. So we have to write that Ka1 and Ka2. So the product divided by reactant. Remember, this is a heterogeneous equilibrium because these are aqueous and this water is a liquid. So we don't include water. So when we write the product, divided by reactant, and same thing, the product H3O plus CO3 divided by reactant, which is HCO3. Then a solution of a carbonic acid has an initial concentration of 0.1. The Ka1 is there. Using Ka1, calculate the equilibrium concentration mole per dm cube of hydrogen carbonate ion HCO3. So Ka1, we already write the expression, which is the product divided by reactant. So the product is there, HCO3, and H3O is there, or we can also say H ion. So when we write the equation, because this was according to Ka1, so H2CO3 dissociate into, you can mention like H plus and CO3 minus, or H2O, HCO plus and CO3 minus. That does not make difference. So HCO is a minus. Now what happened? Initial concentration, the initial concentration is 0.1. So initially it was 0.1. The product will be 0 and 0. Carbonic acid is a weak acid. So at equilibrium, the concentration of this one will be X, the concentration of HCO3 will be X, and the concentration will be 0.1 minus X. So when we write the expression, the Ka1 is the product divided by reactant. So Ka1, that is given, which is 4.7, 4.17. So 4.17 into 10 to the power minus 7. So this will be X, this will be X, and divided by 0.1 minus X. But because X is very small, so we neglect that 0.1 minus X is approximately equal to 0.1. So this will be multiply and we'll take a root. So that will give us the value of X, which is the concentration of HCO3. That will come out as 2.04 into 10 to the power minus 4. This is a way we use for weak acids. Use your answer for B1, calculate the pH, because the concentration of HCO3 and H ion is same X. So then we'll use the same pH is equals to minus log of hydrogen ion concentration. So hydrogen ion concentration is same as the concentration of the acid, which is HCO3. So we'll just substitute the 2.04 exponent minus 4, take minus log, we'll get the pH of this solution. Write the pH either in 1 decimal place or 2 decimal places. Don't try to round off to a whole number. Then state 3 assumptions. Whenever weak acids are there, what are the assumptions we make? We assume that the acid, initial acid, does not dissociate. That is our assumption. First assumption is there. Like at equilibrium, initial concentration of carbonic acid is same as concentration at equilibrium. Practically, it won't be. And second thing, we assume the hydrogen ion which is present in the solution is all coming from the acid. It's not coming from water. And the third thing here, what we assume, because you can see that this HCO3 like this HCO3 can further dissociate. So we assume that this HCO3 does not dissociate. So what our assumption? We assume H2CO3 concentration does not change. It was same as initial. We consider all of the hydrogen which is coming here is from acid, no hydrogen from water. And the third assumption that the product, because the HCO3 can also dissociate or break down. So we assume it is not breaking down. It remains same. Then a carbonic acid form two types of salt. One is carbonate, another one is hydrogen carbonate. A solution of carbonate is titrated with hydrochloric acid. On the grid, sketch a likely shape for a titration curve. Carbonic acid, carbonate required 2 moles of hydrogen ion of carbonate for complete reaction, and 10 cm cube of sodium carbonate of concentration 0.1 is used. Sodium carbonate has a pH of 11.3. 40 cm cube of hydrochloric acid of concentration 0.1 is added. pKa and pKa2 is also given. So pKa means the pH range at which the indicators show a color change. pKa, A1 or A2. So they already mentioned carbonate required 2 moles for a complete reaction, and hydrogen carbonate only required 1 mole. So first, there might be a reaction between HCO3, and then there might be a reaction of CO3. Like directly CO3 might react, or directly HCO3 might react. So here we have sodium hydrogen carbonate solution which is having a P, and we are using a hydrochloric acid. So this hydrochloric acid, the hydrochloric acid might react with this HCO3 or might react with CO3. If a hydrochloric acid react with HCO3, the ratio is 1:1. But if hydrochloric acid react with CO3, the ratio is 1:2. Like we need twice moles of HCl compared to the moles of carbonate. So we start with 11.3. Like we will start with 11.3. So this one is 7, 8, 9, 10, 11. So 11.3 somewhat here. Then we use example 10 cm cube. 10 cm cube of sodium carbonate is there, the total volume. So first, what we might need, this is the volume of hydrochloric acid. So if the hydrogen carbonate is reacting, the ratio will be 1:1. And if the ratio is 1:1, how much acid will be reacting? So 10 cm cube will react because they will have the same ratio. And the pH, pKa2, that is 10.3. So this range will be around 10.3. So around 10.3, there will be a change in pH. And then if carbonate is reacting, carbonate react 2 moles. So it means because the concentration is same, so HCl needed is twice. So the volume of HCl needed will be twice. If we need like 10 cm cube of HCl for reacting with hydrogen carbonate, we need 20 cm cube of HCl, which will react with carbonate, and that will have a pKa of 6.4. So there will be a vertical region of 6.4. And then we are using an HCl. So it started with 10.3. Then we are using an HCl. So this pH should decrease to 1, around 1, till 40 cm cube is added. Is it clear, this graph, that how we complete? Because in a solution, we may have a carbonate ion or we may have hydrogen carbonate ion. If the hydrogen carbonate ion is there, the ratio between hydrogen carbonate is 1:1, but carbonate to hydrochloric acid is 1:2. Like we need twice amount of hydrochloric acid as compared to carbonate ion present in the solution. That's why the volume is twice